All right, let's go over your warm-up so that you are prepared for all your concepts on hypothesis testing quiz. So here we go. So on this first problem, our answer is B. And as opposed to E, I heard some discussion today about E. E is too certain. We are just 90% confident about this value from 59 to 67%. And yet B says that it is possible that the true proportion, it's about population proportion of all Texans who regularly wear sunglasses when outdoors, is 67. Okay. And since that's part of our interval, it could be that. And then this next one, so keeping in mind that on this next one, we were interpreting confidence level. So when we're interpreting that confidence level, we are not referencing our individual specific interval, which is that 16 to 21%. So because of that is going to go ahead and knock off 3 of my answer choices, okay? Because I'm not going to, this interpretation of confidence level is about many, many, many intervals, all the many, many intervals, and how many of them contain, and what size they are, contain the true population parameter. So C and D both talk about the many, many samples and about how 95% of this size, the 95% size intervals, contain. And so then the difference here is the true proportion or the sample proportion. And so it is not about containing the sample, it's about containing the population amount. So that's what makes C the best answer. All right. Number 3 is another one where we have this estimate with the margin of error. So from that, see, we can make our interval. Okay. And so then I know that because, and I think we've seen this problem before, that because we've got this interval containing 50%, then we don't know who's going to win this election. It could be lower, could be higher, but 50% is in there, so we can't make a statement. All right, and then let's remember about our changing in the sample size and how that affects our interval. Okay, so do you remember that because our standard deviation, our margin of error is affected by the size of the 2 things. Okay, so there's a quick review from the first part of this unit that our margin of error is affected by 2 things. And those 2 things are that critical value, inverse norm of one tail, and the sample size. So in this case, we see the sample size from N had 900, N had 100. M, of course, making this a larger sample size, okay, having a larger sample size makes this standard deviation smaller. Being divided by 900 will make a smaller quotient than being divided by 100. In fact, it'll make it the square root of 9 smaller. So what that said, or larger. So here we go. So I know that N is going to be bigger. I do know that. N is going to be the bigger one. So I know they're not going to be the equal, and I know that M is not the larger one. And then it's just a matter of how much larger, 9 times or the square root of 9. And we've talked about several times why it's that square root of 9. Okay. Now, here is our interpretation of our p-value. So remember, we need to have those 3 things. So this is where the investigator is seeing if the average amount of this carcinogen has reduced, okay? So if we're talking about reducing, that's going to play into the more extreme. Which direction would be more extreme? Because if we want a sample this way that would be reducing, then that's going to be more extreme here to the left. So look at what I've shown here. Okay, remember, this is a big deal. This right here is the number 1 wrong interpretation ever. I guarantee you, Anytime that interpretation of p-value is the problem, this will be an option. The number one wrong answer is people saying the p-value is the probability that the null hypothesis is true. That is not correct. We're not talking about the probability that that null hypothesis is in the right place. P-value is about the probability of getting this sample results or something more extreme. Okay? All right. So that then takes us to answer choices B and E. They contain our three parts. It is the probability of getting this sample or something more extreme if the null is true. So both B and E actually have, if the null is true, then the probability is this much. But here's the difference. Observing an average reduction of at least 23 parts per million or at most 23 parts per million. So I got to decide which one of those. So I'm having to decide which way is more extreme. Okay? So that's why I talked about what is this question asking? This question is asking about, has the carcinogens been reduced? So that means I want it to be at a particular point or less. Okay? And so more extreme is less, at least is above. At most is that point or lower. Therefore, it's, oh, I didn't even mark a correct answer here. It's E. Okay? So it is E then. All right, moving on. Number 6. Which of the following must be true? So some of these might be true sometimes, but which one has to happen all the time? So if we were going to construct a 99% confidence interval for the proportion of all district students who participate in the community service activities, so is that population proportion going to definitely be, will be in my interval? Very possibly, hopefully, but not necessarily. Okay, I'm 95% confident, or however much percent confident that 99% confident that it will contain that true population parameter. I don't know with 100% certainty. Okay, so the probability that it contains this, that the interval is the one that contains the population one, not the sample one. So that is B for your answer. And then here's number 7. So this one was quite involved. This problem was one in which you had to go through the process of performing an entire hypothesis test. So, wow, this problem really was about, made you understand the whole hypothesis test procedure and made you compute that procedure to determine the answer. Now, I know you could have reduced some of these answers, okay? And so, in fact, maybe let's just try that out. But, well, let me tell you the right way, and then we'll look and see, could you have reasoned it without even going through all that work, which I think you might could have, but let's look. So, first of all, I wrote some information here, okay? So, I know that it was talking about, of course, the defective buttons or whatever it was they were making. And so they hypothesize, they say it's 3%, but we suspect or we're worried that it might be higher. And the reason I say that is because the company will allow for no more than that 3%. So we need it to be, so we're investigating. So they got a 4%. So because they got this 4%, then they think that maybe it could be greater. Okay, so we are investigating that upper tail. All right, so we come on over here and see, look, the sample results they got was the 4% defective. That's my dog Bella. She can't move. So she's barking because that's her way of communicating to us that she needs to be moved. And we take her outside and we set her in the grass to to go potty, and then she barks, and we bring her inside and set her in front of the food and water. And when she's done, which that's what that is all about, then she barks, and now there's my husband. Here we go. Here's Bella. There's my husband bringing her and putting her on the couch or on her little pedestal, wherever she wants to sit with her person. Okay, so there's our 4%. Is the sample results, okay? And so, but population is stated at that 3%. So our samples should be centered around 3%. So look at my standard deviation. It was made with this population amount, okay, in mind. All right, so I did my z-score. So see, here's my z-score. My p-hat I got was at 1.5 or greater. So there is how I'm getting that p-value, the probability of getting this sample or something more extreme if the defect rate is 3%. Okay, so that was 0.032. So therefore, I would be, that's less than alpha. Let's see, did they tell me alpha? Yeah, they did tell me. They were saying a significance level of an alpha of 5%, okay? So I'm rejecting. So this means that the sample results are significant. And that's actually, I think, what the question is asking. Assuming all conditions are, inference are met. When computing, okay, let's see here. So yes, it is significant. So is it significant? Oh, here's a question. Does the data provide convincing statistical evidence that the defective rate is higher than 3%? Okay, so that's a lot going on there. So yes, it does. So see, I could knock off these ones because it's not no. Now let's look at what's left. It says yes because the sample estimates of 0.04 is greater than the company specifications. So, I mean, yeah, it's greater, but we know you have to know, is it really significantly greater? So that's somebody who doesn't understand hypothesis testing to answer that. So now it's between B and C. Our p-value of 0.032 versus our p-value of 0.064. And so then that's why we had to know our significance level. In hindsight, I can see that they would have chosen 0.064 as the other option. That would have been what the results were if it was a two-tailed test. Okay, but because we went with the one-tailed, because we think it might have increased, then that's why we're going with that. All right, so let's go next. Number 8 is our phantoms. Okay, lots of good questions on this. So we are checking about the Black community, the subgroup of the Black community, and seeing how is that comparing to the overall American rate that we know to be the case. So overall, we've been told that 28% of Americans cannot have a time when they've not been able to afford health care. Okay. So we are now going to make a hypothesis and infer about if it is more severe among members of the Black community. And that's also what our sample results came from. We randomly sampled 801 Black Americans, of whom 38 reported this information. So that means our parameter is about members of the Black community. The proportion of the Black community that is unable to afford health care, not about all Americans. So you must say that it's about the subgroup we're inferring about, the Black community. All right. So we're starting off saying that they're the same as all Americans, and then we wonder if it is more severe. So then our null or our conditions, random, independent, large enough, are stated that it was 801 randomly selected Black Americans. 800 is less than 10% of all Americans. Black Americans, 10% of all Black Americans. And then here was our sample size times P, the 0.28. Okay, and those were both greater than or equal to 10. So our approximately normal model applies. All right, so it is a one proportion Z test. And here we go. See, our sample results were 38%. And our samples should be centered around 28% if Black Americans are like everybody in their ability to afford health care. Oh, wow. Look at this. That Z score, 6.25. Wow, that's alarming. Okay, so this would be something where then legislators or whoever it is that is now going to be addressing this would have statistical evidence, and this is huge. Okay, so because we know our p-value, of course, from that point higher, it look 2.06 times 10 to the negative 10th. Wow, that's pretty close to 0. So of course you can do little squigglies. That p-value is about 0, which is obviously less than alpha. So we are rejecting with very much evidence the null hypothesis. So since that p-value is less than alpha, I am clearly rejecting the null hypothesis. And there's strong evidence that the proportion of the Black community who are unable to afford medical care is certainly greater than all Americans, the 28%. So answer the question, which the question is right here. Do these results provide evidence that the inability to afford medical care is more severe among members of the Black community? So I answer that question. Yes. Answer the question. The problem is more severe among Black Americans than all Americans. All right. Moving on. Was your test one tail, upper tail, one tail, lower tail, or two tailed? Explain why you chose that. Well, it goes back to how you did your alternative. It was a one tail, upper tail, because we were seeing if the problem is more severe. So that would be the direction we were wondering. Okay, we were investigating if it's more severe. Now, explain in context what your p-value means. So, three things. And remember that today, my class members actually liked this null hypothesis portion first. So I'm going to highlight this, and I'm going to say this first because you might prefer to write this actually first in your statement, okay? So if the Black Americans have the same rate in the inability to afford medical care as all Americans, so if the rate of inability to afford health care is the same for Black Americans as all Americans, then there was basically a 0% chance that I would have gotten the results I got, that I would have gotten that sample of 801 Black Americans that showed that 38% of them were not able to afford health care. So it has to have these three things. I highlighted, of course, if the null is true, then there is this probability of getting these sample results. Okay. And so then let's look here. Now we have that thing we had talked about today of the relationship between the confidence interval and HO, the null hypothesis being in there or not being in there. So let's see how this asks this question. So they tell us, hey, a 95% confidence interval that was made off of the sample results we got made this interval right here, 35% to 41%. Does that correspond to the conclusion you made on the previous page? So the conclusion we made on the previous page, of course, we rejected HO, that which said that P is 0.28. Okay, so remember today we discussed that if this HO is clearly not in that interval, the entire interval is above and does not contain 0.28, then look, I'm 95% confident that the true population proportion of the Black Americans that can afford health care is above this 0.28. So I write, yes, this interval does correspond with the conclusion I made with my hypothesis test. And here's why. My test rejected this null hypothesis to conclude that the rate is actually higher, and my interval estimate of 0.35 to 0.41 is completely contained above that hypothesized value of 0.25. Therefore, it makes sense that I rejected 0.28 for a higher value. Okay, so some kind of explanation connecting whether the null hypothesis is or is not in that interval is what I will be looking for. So again, we had talked about this. One final thought. If we rejected the null, then we'd expect the interval to not include the null hypothesis. If you fail to reject the null, then your interval will most likely include the null hypothesis. Okay, so that's what you want to reference when you are seeing if that decision with your test corresponds with the interval that you made. All right. I think that is all of this warm up. That's a lot of information there. Okay. So I hope that going over this helped you and that you understand your hypothesis testing and all those relationships with the interval information and that you will do well on your quiz. So good luck.